Welcome friends. Uh, Today we will see 51st video and video number 3 for revision of chapter number 4. Okay. In this video we will see about few important theories, as well as you will see few questions based on that theory which can be asked as a 1 mark question. Okay. Yesterday you have seen the revision video of that numericals. So we took few numericals which will be helpful to you to solve such type of numericals if it is asked in the unit test. Okay. And we are going to try to give the unit test online, means on the Zoom, and you must have to be honest. Okay. By heart you have to write properly whatever you know, but don't try to keep yourself away from that online test, because it is new for all of us. So we have to give some positive efforts for that unit test. Okay. So best of luck for your unit test. Let us see few theories which can be asked in your unit test. Okay. You don't have to tell anything about this. Okay. Let us see. In this video we will see about the equation of force. Equation of force acting between two wires. These two wires are placed parallel to each other. That means two parallel wires these wires carries electric current in same direction. Okay. So for this you have to take two wires. From these two wires, let us take it is wire number 1. Okay. So this is wire number 1 carrying electric current, that is IA. Instead of 1 we are taking this is wire number A. This wire number A having length. How much length? L. Okay. As we know, when electric current carries, when conductor carrying electric current, around this magnetic field is produced. Okay. Consider this electric current is along x direction. So due to this wire number A, this wire A produce what it produces? It produces magnetic field, which is given by, we have obtained equation in that Biot-Savart's law. Okay, we have obtained the equation by using Ampere's circuital law. With the help of Biot-Savart law, we have obtained the equation for a circular ring carrying electric current, and with the help of Ampere's law, we have obtained equation for a straight conductor, and the equation was mu 0 I upon 2 pi r. What is r? Distance. Let it be. What is I? Electric current. But in our case, electric current is IA. Magnetic field produced due to conductor number A. So this is the first wire which produces magnetic field. Give it equation number 1. Clear? Oh, it is in x direction, so give a unit vector. Which unit vector? I for x direction. Okay? No sir. We have seen in previous videos. It is the equation of magnetic field. So if it is considered as in x direction, so magnetic field is along perpendicular to the plane, means it is along z direction, so it is k. Clear? Okay. Now let us take wire number 2. So wire number 2 is placed parallel to each other, and this both wire having a distance. Which distance? Y. So here the distance between two parallel wire is y. So instead of r, you have to keep y. Is it? Then this wire carries electric current. Which electric current? IB. Again it is along which direction? X direction. So on wire number B, force acting, that is force acting on B due to A is given by F, equation of force, that is ILB, means I, L and B. Magnetic field of first wire, so it is A. Electric current of second wire, it is B. And this electric current, again it is along x direction, so it will be I. Got it? Give it. Equation number 2. Simple. First wire, its magnetic field. Second wire, force acting on it, and it is given by. Okay? Now, put the value of BA here. So, you are getting what we are getting, that is FBA is equal to IB. I L value of BA, that is mu 0 IA upon 2 pi y multiply by k. Got it? So you will see that you have seen in 11th standard I cross k is nothing but minus j. So it is minus I cross k is equal to minus j. So it is minus sign, j will be here. Okay? It is not there in our textbook, but how minus sign come, that I have given idea. Okay? So IB, IA, mu 0 L. So you can write mu 0 IA, IB upon 2 pi y. What remain? L. Keep L here. Okay, why I chose this method? This method is in a reference book. Why I chose this method? Because this negative sign indicates the force is. So this negative sign indicates the force is attractive force. When attractive force? When both the current are in a same direction. So there will be a short question. It is a short question. Depends on this theory. If two wires, they are placed parallel to each other and carries electric current in same direction, if the direction is same, two conductors are parallel to each other, then the force acting on an any one wire due to second must be attractive. And if the direction of electric current is opposite to each other, then the force may be repulsive. Not maybe, must be repulsive force. Clear? So, this is the equation of force acting on wire number B due to A. Okay? There is one more equation. If you will take F BA upon L. So it is known as force per unit length and it is symbolized as small f BA. Right? So this is nothing but force per unit length. Symbol is changed. Force, that is capital, but force per unit length FBA is equal to, now here minus sign for what? Attractive, it is clear. So minus mu 0 IA IB upon 2 pi y. Right? So this is the equation of force acting between two parallel wires carries electric current in a same direction. So this is the theory of 2 marks. Only 2 steps you have to remember. First wire, its magnetic field. Second wire, placed parallel to each other at a distance y. Now the force acting on second wire. Why? Because it is placed in magnetic field of first wire. So force acting on second due to first is equal to, put the value of BA, you will get. Here in our textbook I and K is not there, but there is a direct equation and then after there is a description. If the electric current are in same direction, that force is attractive and in opposite direction the force is repulsive. Clear? So let us see for a few seconds. We will meet after few seconds with one more theory. Let us see. Okay? There is one more question which is moving in my mind, right? What is that question? I have seen so many times in that question paper, either it is of school unit test or any, right? 1 upon under root mu 0 epsilon 0. What is its unit? What is its dimension formula? Okay, you don't have to go for unit of mu 0 and epsilon 0. It is a little bit complicated, but we have obtained this equation and this equation is same as C. Means C means velocity of light in a vacuum. Right? If it is velocity, then this term 1 upon mu 0 epsilon 0, it having unit. Which unit? Simple. Unit of velocity, that is meter per second. And it having dimension formula. Meter means L1 second minus 1, mass is absent, so it is m0. Clear? Good. Okay, from this equation one more definition is there. It is the definition of ampere. Okay, let us see what is it. Right, if you have remembered that to define the ampere by using this equation, what to take? You have to take y. What is y? Distance between two parallel wires is 1 meter. Y is 1 meter. Length of a wire, again 1 meter. Then what? Electric current passing in first wire as well as electric current passing in second wire is said to be 1 ampere. Right? How we have obtained? When these two conditions are satisfied, electric current passing is said to be a 1 ampere, then what about the force? Let us say, okay, this equation, that is FBA by L is equal to mu 0, IA, IB value 1 upon 2 pi. So, what is the value of mu 0? It is nothing but 4 pi multiplied by 10 raised to minus 7 upon 2 pi. So, this will be cancelled out. Okay, and you will get 2 multiplied by 10 raised to minus 7, as it is force per unit length, that is force per unit length, and it having a unit Newton per unit length. Length is in meter inverse. Right? Combine all this, you will get the definition of 1 ampere. How? Let us see. Okay? When two wires having length 1 meter are placed parallel to each other, having a distance, that is y, is 1 meter, then force acting per unit length on one wire due to second is 2 multiplied by 10 raised to minus 7 Newton meter inverse. Then electric current passing through both the wire is said to be 1 ampere. Okay? So, what is 1 ampere? Once again, let us say. Ready? If two wires having length 1 meter are separated by a distance 1 meter, then the force acting on first wire due to second is 2 multiplied by 10 raised to minus 7 Newton meter inverse. Then the electric current passing through both the wire is said to be 1 ampere. So the definition of ampere 1 marks by using this equation. Then the dimension formula as well as unit of 1 upon under mu 0 epsilon 0 is here. Okay? Now let us see one nice theory. It is a why nice theory? Because it says so many things about what about galvanometer. Let us see. Okay. First of all, what is galvanometer? Right? Moving coil galvanometer. Galvanometer, it is a device which is used to measure as well as detect electric current as well as electric potential between any two points. Means this is the use. Galvanometer is used to measure and detect electric current as well as electric potential between any two points. Moving coil about that electric current. Means with the help of galvanometer, you can measure electric current of the range of 10 raised to minus 11 ampere. Okay, means small amount of electric current will pass from the galvanometer. It shows deflection. Means with the help of deflection, we can measure electric current with the help of galvanometer. Okay, now let us see how to convert galvanometer to measure electric current. Got it? As I told you earlier, galvanometer is too sensitive. If electric current increases drastically, then galvanometer shows full scale deflection, and sometimes there is a chances of burn off. Means electric current will increase drastically. The galvanometer may blast. May blast in the sense of it stop working, means it burnt off. To avoid this, you have to convert galvanometer. How? Let us see. If we are using galvanometer to measure electric current, then you have to join. What to join? Shunt resistance. This shunt resistor having resistance RS, right? This shunt resistor you have to join in parallel, and there must be a condition. Which condition? That is, shunt resistance RS must be less than resistance of galvanometer. Means if electric current may increase drastically, as the shunt resistance having low resistance, so most of the electric current will pass through the shunt resistance and the galvanometer is saved. Got it? How? Let us see by figure. So this is a galvanometer having a resistance R, G. Got it? Here electric current I is passing. If electric current increases drastically, then this galvanometer will burn off. But to avoid this, you have to join. What to join? One more resistor having resistance RS, and this RS must be less than RG. So electric current passing through the galvanometer about its range, that is Ig electric current is passing, and most of the current Is will pass from that shunt resistor. Okay, by this way we can use galvanometer to measure electric current. How? By joining shunt resistor having resistance Rs, which is joined in parallel with galvanometer having resistance less than the resistance of galvanometer. Clear? Have a look for a few seconds. Okay? Now, vice versa. If you want to measure electric, not current, then electric potential. If you want to measure electric potential with the help of galvanometer, then contradict to this, inverse of this, means you have to join means it having resistance. RS means series. Here there was parallel connection. Resistance RS, here resistance RS, but to avoid this you have to write only R. Means to convert galvanometer into voltmeter or to use galvanometer to measure electric potential, you have to join a resistor in series which having resistor R. And this resistor having resistance R must be greater than resistance of galvanometer. Clear? So this is for ammeter. So in ammeter you have to connect shunt resistance parallel, and shunt resistance is less than resistance of galvanometer. But if you want to convert that galvanometer into voltmeter, then what to do? Same thing. Galvanometer having resistance Rg. Now here, instead of parallel, you have to join one more resistor, that is R, and this R must be greater than resistance of galvanometer, right? So by this way you can convert galvanometer into ammeter and galvanometer into voltmeter. Is it okay? See, for a few seconds. As we are talking about galvanometer, there is one more thing, one more question, okay, that is of 2 mark question. Explain the construction as well as working of galvanometer. Then how to write, what to write, how to draw the figure. Let us see very fast. Okay, galvanometer, there is a coil which is pivoted vertically and which is moving horizontally. So it is pivoted vertically and allowed to move horizontally. Okay, there is a rectangle coil which is made up of soft iron. So it is a rectangle coil is placed in a magnetic field. So North Pole and South Pole. Here magnetic field B is radial, and this radial magnetic field is provided by that rectangle coil which is made up of soft iron core. Not only that, a rectangle coil gives the magnetic field radial as well as it gives the strength to that magnetic field. Clear? So it is a function of rectangle coil in galvanometer. So rectangle coil provides radial magnetic field as well as it gives strength to that magnetic field. Okay? This coil, spiral coil, is connected with a pointer, and pointer is attached with a scale. Got it? So now it's working. When electric current is passed through the galvanometer, torque acting on it, that torque is given by NIAB that we have seen. And because of that torque, galvanometer shows deflection. When electric current is off, when electric current is zero, galvanometer's pointer will go to its original position. Means there is one more torque. Torque is restoring torque. And this restoring torque is directly proportional to the deflection of a coil as well as deflection of a pointer. Want to remove this proportionality sign? Yes. Then put a constant K. This constant K is known as torsional coefficient of a coil. Got it? Then compare these two equations. You will give NIAB is equal to K phi. Okay? Make a subject phi. Phi is equal to NAB. What is N? Number of turns of a coil. A. Area of the coil. B. Magnetic field. Which radial magnetic field? All these are constant. Not only that torsional coefficient, it is also constant. So what will remain? Only I. So you will get phi is proportional to I. So this is the principle. Means deflection of a coil, deflection of a pointer in galvanometer gives electric current. On this principle that galvanometer works. Okay? On the basis of this, take I, so it is phi by I. From here, phi by I, what is this? It is known as current sensitivity. Got it? From the same equation, if you will find phi by V is equal to, these terms are constant. There is NAB by K constant multiplied by 1 upon R. And this is known as voltage sensitivity. Right? About the current sensitivity as well as voltage sensitivity, you can read from your textbook or from our assignment also. Current sensitivity depends upon number of turns. Means as number of turns increases, current sensitivity phi by I also increases. But as number of turns increases, resistance also increases. Therefore, voltage sensitivity remains constant. Once again, current sensitivity depends upon number of turns of a coil, but voltage sensitivity does not depend upon number of turns, it remains constant. Okay? So, this is about revision number 3 of chapter number 4. Best of luck for tomorrow's test. Thank you.